So we're looking at binary operations. So an operation is said to be binary. Suppose I have star. So we'll say star is the binary operation in a set A if when I get A and B in the set A and then I act these two on the star, I should find an element in A. So for it to be binary, I need to pick two elements or the same element. I act star on those two elements. I should find an element in the same set. If I find an element outside the set, then it's not a binary operation in that set. That's the first thing. The second thing, this very star is said to be commutative if when I act A star B, I get the same thing even when I act B star A. So I can switch them. So the order, if the order doesn't matter, then it's commutative. So in this case, star is commutative. Then star is associative if when I get A star, B star C, so I can act B and C. What I get, I act on A, I get the same thing as starting with A and B and then extending to C. Then we say star is associative. Now let's look at this very nice example. So an operation is defined so an operation star is defined on the set 2, 4, 6. In the table below as follows. A star B is the cell where the row along A and the column along B intersect, e.g. 4 star 6 is equal to 4. So we put the table So 2 star 2, we get 2. 2 star 4, we get 4. And 2 star 6, we get 6. 4 star 2, we get 6. And 6 star 2, we get 4. Then 4 star 4, we get 2. 4 star 6, we get 4. 6 star 4, we get 6. And 6 star 6, we get 2. The first question is this operation a binary on the set? So is star binary on the set 2, 4, 6? So let's see. We said it will be binary if when we add 2 elements from a set, we get an element in the very set. So if you look at these elements here, when we add 2 star 2, we get 2 in the very set. When we add 2 star 4, we get 4 in the very set. When we add 2 star 6, we get 6 in the very set. Okay. So when we add 2, I think for 2 we are done. We now add 4 star 6. We get an element in the same set. We add 4 star 4. We get the element in the same set. And we add 6 star 6. We get the element in the same set. So what we have now is that A star B is always in the set, and hence star is binary in that set. The second question, is the operation commutative? So is star commutative? So let's see. If it's commutative, we require that A star B should be the same as B star A. If we find any case where it fails to be commutative, we don't care about how many cases hold. What we'll say is it's not commutative. Once one fails, it's not commutative. So let's start 2 and 4. What are we getting? 2 and 4, we are getting 4. Oh. So let's check 4 star 2. What are we getting? So the 2 star 4 starting from this 2, then to that 4. So the 4 star 2 will start from this 4, then to that 2. So what are we getting? What is 4 star 2?
It's 4.
The intersection?
6.
6. So we get 6. So now, since 4 is not equal to 6, implying that 2 star 4 is not equal to 4 star 2, then star is not commutative. I don't know if you get it.
I'm just confused. I'm just a little confused with this part, the coordinates part. I didn't know the coordinates, the number parts. How we're getting them?
The ones in the box or outside the box?
The box, the ones in the box.
So the box came as a question.
Okay.
So the numbers were already arranged in that pattern. Ours is to understand what happens to these numbers in relation with the operation.
Okay.
So the first thing we're understanding, if when we add any of these two numbers in this box, we won't come out of the box. There will be no number outside this set. And we notice that all the numbers here are within the original lines, meaning the first line and this first line. So we have 246, 246, and the whole table has 246. Meaning that the operation is binary there. The second thing is we wanted to see if it is commutative. But being commutative is where we don't care about the order. We can pick A star B or B star A. We should be getting the same thing. Now in this case, when we tried 2 star 4, using this row and that column, we got 4. Then we switched. We start with 4 star 2, we got a different number, 6, meaning that we cannot change the order. So because you cannot change the order, it is not commutative.
Okay.
So now, let me put the third one here. Evaluate 6 star 2 star 4. So let's find that one. What is 6 star 2 star 4? So when you have the brackets, you first start with the brackets. So we'll first find 6 star 2. So what is 6 star 2? This row and then this column.
4.
4. So this is 4. Meaning that when we go back to our question, it has now changed. It is now 4 star 4. Is that okay?
Yes.
Okay, now what is 4 star 4?
2.
2. So what we are saying is that 6 star 2 star 4 is equal to 2. So we've also been asked to find 6 star 2 star 4. We now move the brackets, which is almost a definition of associativity. So we now start with 2 star 4. So what is 2 star 4?
4.
So we get 4. So when you go back to our question, it's now going to be 6 star 4. Because 2 star 4 has been found to be 4. So where there's 2 star 4, we bring 4. So now we have 6 star 4. So what is 6 star 4?
6 star 4 is 6.
Is 6. Now, is 2 equal to 6?
No.
No. The fourth question is asking us to check if star is associative. Is it associative? So because we have found that 6 star 2 star 4 is not the same as 6 star 2 star 4, then star is not associative. Is that fine?
Yes.
We have 3 things in binary operations. 1, checking if the operation is binary. 2, checking if the binary operation is commutative. 3, checking if the binary operation is associative. And the fourth one is just the computation now, understanding how to pick numbers, the law of brackets, or such. Okay, so let's do some more examples on the same. Example 2. Given that star is a binary operation on Z a set of integers. Z a set of integers defined as A star B is equal to A minus B squared plus 2AB. A is star commutative. B, evaluate 1, 2 star 4 and 4 star 2. 3 star 5 star 7 and 7. Oh no, I want to check commutativity. And 3 star 5 star 7. And then C is star associative. So let's pick them. So we have A is a star commutative. Now we know that for star to be commutative, we require that A star B be the same as B star A. So let's define B star A. Because A star B is already given in the question, so we have A star B is A minus B squared plus 2AB. Now shall we define B star A? So what will be B star A? Give me the definition.
I don't know.
It will be just following the same. Okay, so the number that sits here is the one that sits there. And then you subtract from it the second number.
Okay.
And then you square them. And when you multiply, you start with the first number and then the second number. So that here the first number is B. So we have B minus the second number, A squared plus 2BA. So we follow the order in which they are written. So the definition respects the order.
Okay.
So if you tell me what is Z star 4, using the same definition, I know that Z is my first number, so I'll say Z minus 4 the second number, minus 4 square plus 2Z4.
Good.
What about 3 star 10? How can we substitute it?
3 minus 10
3 minus 10 squared plus
3 or 2 3 10. Now 2 3 10, sir. Oh yes.
Yes, 2 3 10. In the same way they have appeared on the left hand side, the same way we substitute them on the right. Okay, so now let's show that this is commutative. So if you have the brackets and we have a square outside, the easiest thing to do is to factor out a negative and see what happens. If we factor out a negative from inside, we're going to have negative B plus A squared plus, for integers, multiplication is commutative. So where we have BA, you can write AB. It's the same. Give me n two integers. 2 by 4 is the same as 4 by 2, right?
Yes.
So now, if you have AB multiplied by M, indices allow us to say A to the power M, B to the power M. Or should I say exponents? For exponentials, we're allowed to do this, right? So if we have 2 by 4 to the power 2, what is 2 by 4? 8.
8.
What is 8 squared? 64. Right?
Yes.
Now let's split the power. Let's do 2 to the power 2 multiplied by 4 to the power 2. We're going to get 2 times 4, 2 squared, 4. 4 squared,
16.
16. 4 times 16, 64. So they are the same even if we split the power. So what that means is that this negative outside, we know it has a 1. So we can say negative 1 to the power 2 and negative b plus a to the power 2 plus 2ab. What is negative 1 squared?
1.
1. So we just forget about it and write inside here. We can write it as a minus b. It's the same thing. And we have a power 2 plus 2ab. But if you look at this, it's exactly what we have as a star b, which means that star is commutative. Is it okay?
Yes.
Okay. So let's go to the second one, B. BA, let's find 2 star 4. So how do we substitute?
2 minus 4
2 minus 4 squared plus
then 2 plus 2, 2 and 4.
and 4. So 2 minus 4, we have negative 2
Negative 2.
square plus 2 times 2,
4.
4 times 2, 4 times 4,
16.
16. So negative 2 squared is giving us 4, right?
Yes.
Which is equal to 20. So we also asked it to find 4 star 2. So what would be 4 star 2?
4 star 2 will be 4 minus
So it will be
2.
20. It will be 20. Why is it 20?
Oh, isn't because it's like the same thing. Just that on this one, the 2 came first, and this other one 4.
So you say, since star is commutative, so it doesn't care about the order.
Okay.
That's the main reason why it is 20. Why we can't even solve. Even if we solve, we'll get 20 because we have shown that star is commutative. Okay, so what about the second one? 3 star 5 star 7. So first thing, the brackets. So we'll get 3 star 5. Anyway, when we get the brackets alone, there's no need of putting the brackets. So we are first dealing with this 3 star 5. So in the definition, we should have 3 minus 5 squared plus 2,
Plus 3,
3,
5.
5. So inside here we have negative 2 squared plus 6 by 5, we get 30. So we have 4 plus 30, which is 34. Then we have now, where there is this, we have noticed that this is the same as 30, 34 I mean. So we're going to have 34 star 7. So what do we get?
34 minus 7
Squared
plus
2,
34.
Then
7.
So 34 minus 7, we get 21.
What?
We get 27 squared as 2 by 34, we get 68. So what is 27 squared? I said you should be writing.
I'm writing.
Because when you write, it will be 27 by 27. 7 by 7, 49. We carry 4. 7 to 14. 14 plus 4, 18. 0, 4 carry 1. 4 plus 1, 5. So we have 9, 12 carry 1. We have 6 plus 1, 7. So it will be 7, 29 plus 68 by 7. So 6 by 8. 6 by 7. 8 by 7. 68 by 7, we will get
78.
476.
Oh, 6, yeah.
Then we add, we have 15, 9 plus 6, 2 plus 7, 9 plus the 1, 10, carry 1, 7 plus 4, 11 plus 1, 12. So we have that. Now let's switch. We also find 3 star, 5 star 7. So first we'll start with 5 star 7. So which is 5 minus 7 squared plus 2, 5, 7. So this is negative 2 squared plus 10, 7, which is 4 plus 70, which is 74. So we take back, we now have 3 star 74, which is 3 minus 74 squared plus 2, 3, 74. And this is equal to negative 71 squared plus 6 by 74. So what is 71 squared? 170749. So we have 1405. So we have 5041 plus 6 by 74. So we have 6 by 4, 24. Then 6 by 7, 42.
42.
42
Plus
plus 2, 44.
4.
So when we add this, we get 5, 4, 8, 5. So the third question was asking us to check if star is associative. Now star is not associative. Why?
Because we're not the same.
Because 3 star 5 star 7 is not the same as 3 star 5 star 7. So once one case fails, then all the cases fails. We don't care even if all the other cases are true, provided one fails, then we can make a statement that in general, star is not associative. Okay, let's do another example. The third one. So given that A star B is equal to 2 to the power A minus B plus AB, where star is binary in R the set of real numbers. A is star commutative. B, evaluate 1, 3 star 10. Won't it be too big? So let's do with 5 star 3 and 3 star 5 and 2 5 star 2 star 4 and 5 star 2 star 4, and then C is this guy associative. Okay, so let's see. A, we know that for it to be commutative, we require that this should be true. So let's check. We already know that A star B is 2A minus B plus AB. So let's start with B star A. So how do we define B star A?
It's going to be B star A is equals to 2B minus A
2B minus A plus
BA.
Good. Now, is this, so if we look at BA and AB, these two are the same, right?
Yes.
So all we need to do is to check if B minus A is the same as A minus B. Because if they're the same, then everything else will be the same, right?
Yes.
So if I give you a number 4 and I say it's equal to A, then it must be clear that 4 minus A should be 0. Right?
Yes.
If I get two equal things and subtract, I must get 0. So if I get 10 and subtract 10, I'll get 0. So if B minus A is equal to A minus B, then when we subtract them, we should get 0. So let's subtract them. B minus A minus A minus B. This is going to be B minus A plus B, which is 2B minus 2A. This is non-zero, right? So we are saying because B minus A is not equal to A minus B, B star A, or we can go step by step, that 2B minus A is not equal to 2A minus B, and hence B star A is not equal to A star B. Thus, star is not commutative. Is that okay?
Yes.
Good. So let's go to B. We evaluate 5 star 3. So what will be 5 star 3?
5 minus.
So it will be 2, 5 minus 3
5 minus 3.
plus 5 multiplied by 3.
3.
So we have 2 to the power 2, which is 5 minus 3, plus 5 by 3, 15.
15.
So we get 4 plus 15, which is equal to what? 19.
19.
Okay, let's also find 3 star 5. So this time around, we cannot say it is 19 because it's not commutative.
Yes.
So we have to solve. So that will be 2, 3 minus 5
Minus 5.
plus 3, 5,
4.
which is 2 to the power negative 2 plus 15, because 3 minus 5 is negative 2,
Yes.
plus 15, which is, so when we have the power negative, we can as well take everything in the denominator so that the power becomes positive. I hope that doesn't confuse you. So that we have 1 over 4 plus 15. And this is the same as 15 by 4. We get 60. 60 plus 1, we get 61 over 4. So for sure, star is not commutative, because I've even found an example where 19 fails to be, where 5 star 3 fails to be 3 star 5. They are not equal. Okay, so let's do the second one. So we'll do it from here. 5 star 2 star 4. So start with 5 star 2. So 5 star 2 is the same as 2, 5 minus 2 plus 5 by 2. This is 2, 3 plus 10, which is 8 plus 10. So we get 18.
18.
So where there is the first one, now we are dealing with 18 star 4. Oh, what a big number. So we have 2. So we have 2, 18 minus 4 plus 18 by 4, which is 2. 18 minus 4 is 14 plus 18 4.
72.
72, right?
Yes.
Okay. Okay, then, well, now we cannot get to 2 to the power 14. Okay, so let's just get the other part. That is 5 star 2 star 4. So 2 star 4 is 2, 2 minus 4 plus 2, 4. That is 2 negative 2 plus 8. This is 1 over 4 plus 8. So we get 32 plus 1, that is 33 over 4. So we take, now we are looking for 5 star 33 over 4. So this is going to be what? This is going to be 2, 5 minus 33 over 4 plus 5, 33 over 4. So obviously, this cannot be the same as that one. They are not equal. So for C, it will be easy to conclude. We'll just say C is not associative, because we have a case that fails. These two cannot be the same. The other one has a fraction 23 over 4, and the other one has 9 fractions, 214 plus 72. So the two numbers won't be equal, no matter what happens. So that you don't get confused. Okay, so we have this. So how is it?
It's okay.
It's okay.
Yes.
So can I give you one question to try?
Okay.
So the exercise, so given that star is a binary operation on R defined as A star B is equal to 3A minus B squared plus, or should I say now minus AB. A is a star commutative. B, evaluate 2 star 1 and 1 star 2. And second, 2 star 3 star 1 and 2 star 3 star 1. Then is star associative. Okay, so you have this to try and submit when done.
Okay.
Good day. Thank you.